like on a national level, the Department of Education talks about what students should learn. On a state level, they say every Algebra 2 student should learn this list of things. And then that promotes equality so that every algebra student in the state, no matter what district you're in or what county you're learning the same material. You have the same opportunity to learn it in advance. So when you see the standards, just know we're following right along with them, that the content's not like made up. We're not doing it on a whim, that it's kind of the same throughout all the classrooms. And then you have a chance to practice it, and then you'll be given an assessment. And if you can do it, we document it. If you're not successful at it, we document it. We let the state know in your transcript, these students show that they can do it. These students show that they cannot do it just yet. And then you do it again if you can't. And if you can, then you move forward. So it's very systematic. It's not like, why are we getting tortured with these standards? It's a whole list of things that we're supposed to do. So our goal today is to write equations giving a vertex and a point. So here's the vertex form you should have written down. Here's the vertex. We're going to plug it into H and K. Last week, Thursday and Friday, we worked on graphing. And so you have that handout, and we're going to check your graphs today. And the steps for graphing are writing ABC down, doing the formula negative b over 2a, plugging that answer in for x, finding the vertex, plotting the vertex, and making a table and making a whole graph. So that was last week. Today we are moving away from graphing. After we check those, we're not graphing anymore. We're writing equations. So if you prefer that, what we're going to be doing is we're going to be plugging in numbers here, and we're going to plug in numbers here, and then we're going to do like PAM does, and we're going to find A. So like more like kind of algebra stuff instead of drawing pictures. And then we're going to write equations. So it's going to feel a little bit more like plugging in and simplifying than it has probably for a while now. I feel like we've been talking about graphing and stuff for a while. All right, let's head to page 141 and look at our standard that you're writing. Ooh, you want to skip to that. All right, you were asked to write the one ending in 3.4. Write a quadratic function to represent the relationship between two quantities from a graph, a written description, or a table within a math or real-world context. So the two problems assigned Friday, 29 and 30, those were real-world context problems. We're definitely going to have to go over those. The real-world context is very important. So we'll talk about those, and then the rest of the problems today are from a table of values. All right, you guys have had a while to work on that. Let's go back here. And up, up, up. Up, up, up. One more up. Here's number 17 from the assignment Friday, page 132. And I can zoom in on the table. If you got stuck, if you were plotting points and you're like, none of this makes sense, it's not working out, the first thing I would check is your answer to your axis of symmetry. Did you have a -1 or a +1? If you were working with +1, then things don't really line up so clearly. It has to be negative. So I encourage you to go back, rework it with -1. Plugging in -1, you get a 0. Making a table should look about like that. So now's your chance to ask about 17. Ask about your calculator. Ask about your numbers you got. And I know you had 17 in your book, so I'm probably not going to land too long on the odd answers. Are there any questions about this one? All right, then here's 18. Now this one's not in the book, so I want to land here a little bit longer. Let you guys look it over. So Noah, how are you getting those points without making a table? Or do you have a table on a different paper?
What do you mean?
Like, I have all this work.
Oh, I just used the 3 points that I already have.
Oh, you're not getting 5 points?
No,
Okay.
and then I just wrote like vertical stretching. 3.
Oh, okay, so you're justifying it with the A?
Yeah.
That works. Good job. Mm-hmm. Oh, 18 and 17. Yes, 13. Sorry if that's too tiny. Why you just gonna do these now? Is there an intro or like you have to do something really heavy that so you could write on there, you could write on there parent function, or you could write congruous parent function, or you could write value instruction, like that. Wrap it up with something. Brian, that's 17 on there. Alright, who's got a question about 18? Let me show the picture. Nice stretch on there. Arrow's going upward. I see your graph's coming. Your graph, 17, 18, 19.
What page is that on?
That's it. That's it. Okay. Yeah, how come mine looks different? Oh, you just put yours. Did you put it on there? Okay. I'll put it up. I'll put it up. So we're fine? Oh, yeah. So we're fine. I'm looking at grades right now. 147. Alright, I'm going to show 19, and then I'm going to talk about the word problem. That one I should see arrows pointing down. It should be very skinny. It has a stretch of form. And the video, if you weren't here Friday, a number of you, I'm recording these answers right now. So the video for today will show the work and answers. If you're not sure how to do it, you can pull it up and see if it makes sense. It doesn't always make sense when you look at it at home, but something at least. Any questions on 19? The arrow's going down. It's a stretch of 4, so it's quite skinny. All right, now the word problems, we really have to just emphasize there is a word problem on your test for this chapter. This one's about a basketball, a shot put. Your test has a volleyball, a golf ball in one of them, and then I think a shot put in another. So just a guaranteed test question here as far as word problems go. The reason for that is every ball launched on Earth follows a parabolic line. And when you look at the relationship between height and time, it's a quadratic relationship. So a lot of people want to know, like, why are we doing this math? Like, how is this relevant? Well, it's actually relevant for everything projected ever. So you've seen a lot of quadratics in your lifetime. And what's behind that is a quadratic equation. So it's a little bit overwhelming because of the decimals and the negatives. So I just encourage you to use that fraction button in your calculator or do it by hand if you're motivated. There is a student in third period who's doing this by hand, so don't back down. I know some of you guys in here are up for the challenge, but so negative b over 2a, lo and behold, works out to be a solid 25. So that means after the basketball was thrown 25 feet, it's not landing yet, but at 25 feet distance, it was hitting its highest point, the vertex. So when you plug in 25, the highest point was 18.5. After that, at 26 feet, it starts going down again. So just a word problem where you're asked about what is the highest point of the ball. No, you're looking for vertex. It's actually just extra information. You don't even, you're probably thinking, oh, like geometry, like we did so much with angles, but no, you do not need that 45 degrees anywhere in there. I think it's just helping you understand, like, it's not like you're throwing it straight up. You're not, like a shot put is, you're really trying to get it kind of far, but it's like a 45-degree shot, But you don't need that number for the math. You're just finding the vertex. Let's look at 30. See how you did. The shot put actually goes a little bit further. When it hits its highest point, it goes 35 feet. Not quite as high though. 18.25 feet high. I'm gonna read this. So I think the word problems are very important is what I want to say. Guaranteed test question. What are we going to do? Put a star on it or something? Maybe fold that page down on your book and write on there test question? Would you guys flip through and see that in a couple of weeks when you're studying? Would you see test question written on top here? The path of a basketball. Yeah. They're the same style, right? Okay. So the test question's like that. But it'll be about like a golf ball or a volleyball or something. There's also one about a diver, like a person jumping off a diving board. That's also a parabola. Okay, who's got a question about the math on 18? All right, if there's no questions, let's get into today's notes. These notes can be taken in bell work, underneath bell work. Also, if you didn't get to the word problems, you're welcome to come in after school today and work on it today or Friday if you need to work on anything you haven't gotten done. All right, kind of a lot of notes today. I'm looking for this to be in your binder on your next binder check. I will do one more binder check before the end of first quarter. So I'll be checking this under bell work on September 22nd. I'll be checking for these steps. And these steps are for chapter 2.3, writing an equation in vertex form. Yes. As long as when I ask you for vertex form notes, you can find it quickly, I'm fine with it, yeah. Yeah. No, what I mean is when I do it, I'll be asking you to flip to this date. Oh. Yeah, yeah. So it's kind of drawn out into 7 steps. You do not have to write it word for word. You can abbreviate. You can take out words. You can shorten it how you want. I just want to see all 7 steps. The first step is to write vertex form, which we already did for bell work. So this is your second time writing it today. And then we're going to plug in the vertex, HK, and we'll plug in another point, XY. And then step 3, solve for A. And that's where you actually get to do some adding, subtracting, multiplying, dividing. Solve for A. And then we're going to start all over again in step 4. I'm going to pause and let you guys get to it in quite a moment. Now, these exact steps are shown on page 142. So if you don't like the way you're written, check out 142.
That's just a different one. It's a touch screen. I actually can't fix those, but that's just a new
Perfect, thanks.
good thing.
So if you read these steps and they look like gobbledygook, jabber jabber, you go to page 142 and you read how the textbook writes it. And the steps are shown there with an example. Okay, I'm gonna zoom. And there's the last of it. So step 4 is kind of like a start all over again point. You'll see when we do our example. And when you're ready, oh, not good. Sorry. There it is. When you're ready, we're going to page 142 and doing number 1, or 143, number 1. In step 4, we do it all over again with vertex and A. We're going to have to FOIL or use the box method or some sort of distribution. Distribute A, and you're done when you're in standard form. So with this many steps, sometimes it's hard to figure out what's our end game, what's our goal. The goal is standard form. So start with vertex and in standard form. And I'm going to do 2. The first one's kind of shorter, short and sweet, and then I'll do the first one from your assignment. That will require some more steps. Okay. So for the first example, you guys can do it right in your book on page 143. Gray box number 1. Yes.
Is it the point where it stops like increases and it stops and then decreases?
Yes. Very well said. Where it increases, stops, and decreases. So what is it? Steps 2 says you plug the vertex into the other point. So we've just been given a table here. How do we know which one is the vertex? A lot of students will incorrectly think the first point's the vertex, but no, it's vertex is a middle point, right? So do you see something middly about any of these points? Which one do you see middly, Adam? 0, 1 is middly. So Ella says it increases and then decreases. Adam, how do you see this as the middle?
It goes from like the x to 17 to -2, and then you subtract it, but in the middle. So.
Yep. The way I see it is when I see numbers repeated, when I see symmetry around it, I know I have a vertex. A lot of students will think it's always the third point. This could show up anywhere in here, but the vertex is in the middle of the repeat because it's a center point. It's a turning point. The middle ground. So we're going to call 0, 1, we're going to call that H and K. So we need to plug 0 and 1 into H and K. And this problem will be a little bit short because we're working with a 0, but the next one we'll use all 7 steps. All right, what about x, y? I'm going to use the very first ordered pair for the point x, y. So this right here is going to be our x, y point, -4, -3. I'm going to plug in that to the x and the y, and then I'll be able to find a. So -3 equals A, -4 minus 0 plus 1. Plug in HK, plug in XY. Your objective is to find A. A is a super important value. I am always going to use the front one. Yeah, there's one word problem we do at the end of the chapter where it makes sense not to use the front one. But you can actually pick, like if you like working with zeros, you could pick a different one. But to be consistent, I'll pretty much always be using that one. Okay. So now it's just kind of a PEMDAS moment. Do your subtraction, do your squaring, do your mathing to find the A value. -4 minus 0 is -4, and -4 squared is 16. So we've got that simplified to A parentheses 16. That's the same as 16A. So this is all step 3, find A. Put my line here, subtract 1. Almost done. I'm going to divide by 16. And -4 divided by 16 is A, so -1/4 or -0.25. Just keep it a fraction. So to check in with you, that is the answer to step 3. Sometimes students will be like, man, I just did so much work, I have to be done. And then they stop, but this is like halfway through. Step 3, find A. So in order to find A, we plugged in H, K, X, and Y, and we were only left with one unknown A, and we were able to find it. What's step 4? Okay, we're going to start it. We're going to do that all over again. Start over. This time we're going to use HK like we did originally. And we're going to use the new A value that we just found. And we are not going to mess with X, Y. So this time we're just using H, K, and A. And we're going to leave X, Y in it. There. Okay, so that means I got Y equals -1/4 X minus 0 squared plus 1. So on the second time around, I put the H, the K, and the A I just calculated. And then from there, it's simplify. Like the book probably says just simplify. And so in my steps, I put FOIL or use box method. If this wasn't a 0 here, we would have to write this out side by side and FOIL it, but zeros are going to be a little bit easier. This is -1/4 x squared plus 1, -1/4 x squared plus 1. And this particular quadratic happens to not have a b, so it's a little bit shorter, it being our first example. So that's done. That's standard form. So this is a parabola that's up 1. Arrows are pointing down because it's negative, and it's a vertical shrink of 1/4. 0.25, the original parent function. When you're ready, I'm going to do one more with you, and that's number 1 from your assignment. So go to page 147, and we'll do 1. You've been assigned 1, 3, 9, and 10. Should I do 10 instead of 1? It's the only even one up there. You guys want me to do the even problem from the assignment or number one? 147. Let's do the even. Let's do 10. I'm going to do one problem from your assignment, which is written over there. Page 147, 139, and 10. Ooh, look at all the work. There it is. It's already done. Okay. Same steps. All right. They're giving us a vertex and a point. So I know vertex is HK in the model. So I know what I'm plugging in the H spot. I can see what I'm plugging in the K spot. And the point will be the other XY. Yeah. Thanks. Thank you. 148. If you can't find this, check 148.
What are the numbers here?
1, 3, 9, 10. So y'all plug in and find A. I'll wait a minute. I'll let you work for a moment before I get through it. Got it, Jacob? You got it? Anybody else find it yet? Two people? Anybody else find it yet? 3 people? James, you find it yet? 4 people? Okay, you found it? There you go. First step, H and K go in. Next step, X and Y go in. Now I'll solve for A. Oh my gosh, 9 and A look so similar sometimes. Anybody else get negative 1/3? Okay, very good. We did it. We found it. So that's half the problem is finding A. Now we start all over again. We go again. This time we just use HK and A. We leave X and Y. And this is where I didn't get to show you on that first problem. The first problem had a 0 in it. Right here, I have to write this out and distribute correctly. So you can either consider it FOIL or box, whichever you want to do. I'm going to do X minus 1 times X minus 1, and I have to distribute this correctly. I have to multiply it out. I know some of you like it like this. You can do that also. Or X minus 1 squared. We're at like 4 out of 5 points right now. This is like step 6. We're almost done. We're almost in standard form. Next, I can distribute the negative 1/3. I distribute it, careful not to go all the way to the 9. Multiply it here, here, and here into these parentheses. And if you want to be really efficient in that calculator, just do it. Just, negative 1/3 times negative 2, feel free to just put that right in the calculator. And then lastly, you're going to combine these constants. The parentheses are gone and you can combine them any way you like. I'm going to keep it as a fraction. 26 over 3. And then here's your answer. A pretty complicated standard form quadratic. So that's the only even question you've been assigned. The rest of them are odd, so you can check. And you're obviously still learning, so definitely check and see, well, I didn't even get the A right, like you can look and see, did you get the A value right? If you feel like you're getting stuck right around here, normal, like don't stress out and quit. We'll talk about it again tomorrow. We do this all over again tomorrow, so you need to move through the steps so you know where you're getting stuck. So get right to it. 1, 3, and 9. I think the bell might be just about to ring though.